Good morning, students. Welcome to the online CET NEET JEE classes. In previous video, we already discussed about some multiple choice questions on organic chemistry chapter. In this video, I am going to discuss some more multiple choice questions on the same topic with explanation. So let's move with the first question. Students, the first question is it is present in your CET material in the topic of exercise 2 conceptual multiple choice questions. In that first question, how many stereoisomers are possible for tartaric acid? Observe carefully, students. How many stereoisomers are possible for tartaric acid? Yes, students, you know stereoisomerism means isomers having same molecular formula and there is a special arrangement of atoms is observed. Is it right? Yes. In presence of geometrical isomerism, there is a special arrangement around the double bond, means cis and transform visually it is appears, and another one optical isomerism. Yes, optical isomers are observed due to the plane polarized light. Is it right? Yes. So, students, when you come to the point of this question, means stereoisomers possible in tartaric acid. At the time, first you know the structure of tartaric acid. Yes, students. And one more thing you remember here, tartaric acid is an example of a symmetrical molecule having two asymmetric carbon atoms. Remember, tartaric acid, it contains two asymmetric carbon atoms. In such case, the number of optical isomers you can calculate by using one formula. First, I write the structure of tartaric acid. Carefully observe, students. Okay, structure of tartaric acid is COOH, and here one carbon atom, it contains OH. Next, another carbon atom containing HOH, and in the bottom side another COOH group. Yes, students, I told you the tartaric acid, it contains two asymmetric carbon atoms. What are asymmetric carbon atoms? I think you know. One of the carbon atom, if it is surrounded by different groups, then it is a symmetric carbon atom. Yes, observe here, when you come to the point of this carbon atom, I write here star mark because this carbon atom, it is an example for a symmetric carbon atom, because here it contain one H group, one COH group, one OH group, and one this entire group. Is it right? Means around this carbon atom there are four different groups, therefore it is one of the asymmetric carbon atom. And see here, this is also a symmetric carbon atom because here OH is present, here COH is present, here also hydrogen, here entire would go. But when you observe both the symmetric carbon atoms, the involved groups are same here. Yes, here one OH, and this carbon atom contain also one OH, and here COH group, here also COH group, here H, here H, means it is one of the symmetrical molecule containing two asymmetric carbon atoms. During this time you can calculate the number of optical isomers in the given compound using this formula. As I write the formula here, that is 2 to the power of n minus 1 equal to 2 to the power n. N here, this indicates the number of asymmetric carbon atoms. Here this n indicates the number of asymmetric carbon atoms present in a molecule. Yes, here 2 minus 1 means I write only 1. Therefore, there are two stereoisomers. What are those two stereoisomers? If you want to write the structure, I write the structure also. Yes, I write here one is COOH, CHOH, and here CHOH, and here COOH, and another structure COOH, and here this one H and this one is OH, and here COH, and this one is H, here COOH. Okay students, when you observe this type of structure, here COH group is present, here OH is group is present. Therefore next, if you observe the priority, it's have high priority. Next this one OH, so we move with the clockwise direction. Therefore the name of the given compound is D-tartaric acid. D-tartaric acid, is it right? S. And here if OH group is present on another side, if you change, I change this one here. If I write OH and this one is only H, here we move with anti-clockwise direction. Therefore this is an example for L-tartaric acid. L-tartaric acid. Therefore two isomers are possible here. Therefore the correct answer for this question, you get value 2 in presence of the respective formula. Is it right? 2. Therefore option A is the right answer. A 2. Yes. Next question number 2 students. Mesotartaric acid is optically inactive due to the presence of, yes, observe carefully, mesotartaric acid is optically inactive due to the presence of, yes, options are given here. A, molecular symmetry, molecular asymmetry, external compensation, two asymmetric carbon atoms. Students, remember, mesotartaric acid is optically inactive due to the presence of molecular symmetry, and it is optically inactive due to the internal compensation. As remember, mesotartaric acid is optically inactive due to the presence of molecular symmetry. Molecular symmetry is observed here. It is optically inactive due to the internal compensation. Is that the effect of one half of the molecule is neutralized by the other. Why? If yes, students, if you observe the tartaric acid structure, I write here HOH, and here I write HOH, and here COOH. Is it right? Yes. Observe here, if you draw a plane here, at the time, here one H, here also one H, here OH, here also OH, here COH, here also COH in the mesoform. Is it right? Yes. Both the, here in this compound, both the part have same components. Is it right? Yes. Therefore there is a molecular symmetry is present. Here the effect of one half of the molecule is neutralized by the other. Therefore the correct answer for this question is option A. Option A is the right answer. Hey students, question number 8. The stability of the compounds, as with respect to structures they mentioned the numbers. First one cyclopropane, cyclopropene, next one cyclopentane and cyclohexane. Among these, the stability of the compounds in the order, ಯಾವುದು ಹೆಚ್ಚಿಗೆ ಸ್ಟೇಬಲ್ ಅದ ಅಂದರೆ ಅದನ್ನು ಏರಿಕೆ ಕ್ರಮದಲ್ಲೇ ಕೊಟ್ಟಾರ. ಯಾವುದು ಹೆಚ್ಚದ ಆಮೇಲೆ ಯಾವುದು ಕಡಿಮೆ ಆಗ್ತದ ಆ ಥರ ಬರಿತಾ ಹೋಗ್ರಿ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಎಸ್ ಸ್ಟೂಡೆಂಟ್ಸ್, remember, cyclohexane means, when you observe these structures, cyclohexane means fourth structure. Cyclohexane is non-planar and it has chair conformation also. Yes students, observe carefully. When you observe the fourth one structure, it is usually not planar structure because you write the structure in chain form also. Yes, I write here chain form structure. Yes, This is the chain form structure. Number of carbon atom here also 1, 2, 3, 4, 5, 6. Is it right? Yes. Means it is not usually in planar structure. In this conformation, the bond angle is normal tetrahedral angle. As usually in presence of cyclohexane, means non-planar structure, the bond angle observed usually it is 109 20 degree. Yes, bond angle observed here 109 28 minutes, and there has no angle strain. There is no angle strain, hence it is more stable. Yes, remember, due to the absence of angle strain and non-planar structure, it has high stability, or it is more stable. And when you observe the other molecules are nearly planar, when you observe other structures other than fourth one, usually they are nearly planar, and hence stability depends upon the angle strain in accordance with the Bayer strain theory, since cyclopropane has higher angle strain. ಹೈಯರ್ ಆ್ಯಂಗಲ್ ಸ್ಟ್ರೇನ್ ಅದ ಅಂತಂದರೆ ಅಲ್ಲಿ ಸ್ಟೆಬಿಲಿಟಿ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಎಸ್ ದೇರ್ ಫೋರ್ ವೆನ್ ಯು ಅಬ್ಸರ್ವ್ ದ ಗಿವನ್ ಆಪ್ಷನ್ಸ್, ವಿಚ್ ಒನ್ ಕಮ್ಸ್ ಫಸ್ಟ್? Cyclohexane has more stability and cyclopropane has higher angle strain, means stability becomes less. They are inversely proportional. Yes, therefore the correct answer for this question, fourth one is first, and next last one is first one. Students, the order of the stability becomes fourth one is greater than third one, is greater than first, is greater than second here. Students, if you want to know more explanation about this question, use the formula, and I write the values here. If I write 109 degree 28 minutes minus 60 and divided by 2, use this formula, at that time it becomes 24 degree 44 minute. Cyclopentane means third structure. It is more stable than cyclopropane. Remember, cyclopentane third structure, it is more stable than cyclopropane, means one first structure. Further, because of the presence of double bond, in a three-membered ring. Yes, students, cyclopropene means second structure is the least stable. Yes, remember, second structure means cyclopropene is the least stable. Okay, therefore the correct answer for this question is fourth one, where your order is present in the options. Fourth one, third one, first one, and second one, means option A is the right answer. Okay, students, next move with another question. Question number 13. Which organic structure among the following is not an isomer of the compound? Which organic structure among the following is not an isomer of the compound? Okay, students, first observe the given compound and its molecular formula, write down separately. Then you observe the given options. Which one it follows the same molecular formula, then it is your answer, because it is the isomer of the given compound. Okay, students, first observe the given compound carefully. What it involves the molecular formula: CH3CO, CH2, 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 CH3. Okay, students, when you observe carefully, the structures A, C, D have the same molecular formula. Yes, structure A, C, D have same molecular formula. What is that molecular formula? C6H12O. Yes, option A, C and D have same molecular formula. ನೀವು ನೋಡ್ರಿ ಇಲ್ಲಿ A, C, D ನೋಡಿದಾಗ ಅದರಲ್ಲಿ ಏನು ಕಂಡು ಬರ್ತದೆ? 6 ಕಾರ್ಬನ್ ಇದ್ದದ್ದು, 12 ಹೈಡ್ರೋಜನ್ ಇದ್ದದ್ದು, 1 ಆಕ್ಸಿಜನ್ ಇದ್ದದ್ದು ಕಂಡು ಬರ್ತದೆ. Yes, and your given compound also contain C6H12O. ಹಾಗಾದರೆ ಈ ಗಿವನ್ ಕಂಪೌಂಡ್ಗೆ ಅಂದರೆ ಕೊಟ್ಟಂಥ ಕಂಪೌಂಡದ್ದು ಎ ಸಿ ಡಿ ಏನಾಯ್ತವು ಐಸೋಮರ್ ಅದು. ಹಾಗಾದರೆ ಆನ್ಸರ್ ಯಾವುದು? ಅವ್ರು ಏನು ಕೇಳಿದ್ದಾರೆ ನೋಡ್ರಿ, ನಾಟ್ ಆ್ಯನ್ ಐಸೋಮರ್ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಬಿಕಾಸ್ ವೆನ್ ಯು ಅಬ್ಸರ್ವ್ ದ ಆಪ್ಷನ್ 3 ಹಿಯರ್ ಇಟ್ ಕಂಟೈನ್ಸ್ 1 2 3 4 5 6 carbon atoms. Okay, C6, but number of hydrogen atoms here H3 means 3 4 5 6 7 8 9 10. Is it right? Yes, C6H10. Number of oxygen atoms here only 1. Yes, it follows molecular formula C6H10O. Okay students, remember structures of the given compound A, C, D have same molecular formula C6H12O, while B has C6H10O as the molecular formula. Therefore option B is not an isomer of the given compound. Therefore answer is option B. Option B is the right answer. Okay students, next question, question number 14. The least number of carbon atoms in alkane showing isomerism is. The least number of carbon atoms in alkane showing isomerism is. Students, observe the given options also carefully. Option A is 3, option B is 1, option C is 2, option D is 4. Remember one thing students, in presence of alkanes, the minimum number of carbon atoms to show isomerism as if, observe here, if the compound containing the chain like this. Yes, here this one is the first carbon atom and this one is the second carbon atom. Okay, observe carefully the question. The least number of carbon atoms in alkane showing isomerism. ಎಸ್, ಈಗ ನೋಡ್ರಿ, ಸಪೋಸ್ ಈ ಥರ ಕಾರ್ಬನ್ ಆ್ಯಟಮ್ ಇನ್ವಾಲ್ವ್ ಇರ್ತಕ್ಕಂಥ ಚೈನ್ ಇತ್ತು ಅಂದರೆ 2 ಕಾರ್ಬನ್ ಆ್ಯಟಮ್ ಇತ್ತು ಅಂದ್ರೆ ಇದನ್ನು ಈಗ ನನಗೆ ಐಸೋಮರ್ ಬರೆಯಕ್ಕೆ ಬರ್ತದೆ ನೋಡ್ರಿ. ಸರ್, ಈ ಕಾರ್ಬನ್ನಿಗೆ ಇಲ್ಲಿ ಸಿ ಎಲ್ ಅಟ್ಯಾಚ್ ಮಾಡಿರಿ, ನಾ ಇನ್ನೊಂದು ಬರಿತೇನೆ ರೀ, ಇ ಸಿ. ಹಾಗಾದರೆ ಇಲ್ಲಿ ಸಿ ಎಲ್ ಬರಿತೀರಿ ಅಂತ ಅಂತೀರಿ ನೀವು, ಹೌದಾ? ಈಗ ನಾನು ಇಲ್ಲೊಂದು ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಗ್ರೂಪ್ ಯಾವುದೋ ಅಟ್ಯಾಚ್ ಮಾಡೀನಿ ಅಂದರೆ ಐಸೋಮರ್ ಬರೆಯೋಕ್ಕೆ ಚಾನ್ಸ್ ಐತನ್ನು ನೋಡಬೇಕು. ಎಸ್, ಈಗ ಈ ಸ್ಟ್ರಕ್ಚರ್ ಸೇಮ್ ಅಂತಿರೋ ಏನು ಬೇರೆ ಬೇರೆ ಅಂತಿರೋ ನೀವು? ಇವಾಗ ಇಲ್ಲಿ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರಿ 1, ಇದಕ್ಕೆ 2 ಅಂತ ಕೊಟ್ಟಿದ್ರಿ. ಇವಾಗ ಏನು ಮಾಡ್ತೀರಿ? ಇದಕ್ಕೆ 1 ಅಂತ ಕೊಡ್ತೀರಿ, ಇದಕ್ಕೆ 2 ಅಂತ ಕೊಡ್ತೀರಿ. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಕೂಡ ಏನಾಯ್ತು ರೀ, 1ನೇ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ಏನಾಯ್ತು, ಸಿ ಎಲ್ ಗ್ರೂಪ್ ಅಟ್ಯಾಚ್ ಆದಂಗೆ ಆಯ್ತು. ಹಾಗಾದ್ರೆ ಇವಕ್ಕೆಲ್ಲ ಐಸೋಮರ್ ಅಂತೀರ ನೀವು? ಅಲ್ಲ, ಅಲ್ಲಿ ಸ್ಟ್ರಕ್ಚರ್ ಏನಾಗಬೇಕು, ಡಿಫ್ರೆಂಟ್ ಆಗಿ ಕಂಡು ಬರಬೇಕು, ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಸೇಮೇ ಇರಬೇಕು. ಎಸ್, ಹಾಗಾದರೆ ಇಲ್ಲಿ ಬರೋಂಗಿಲ್ಲ. ನೆಕ್ಸ್ಟ್, yes, if position change like this, then it becomes identical but not isomer. Okay, next I take 3 carbon atoms. Okay, here this one is 1 2 and this one is 3. ನಿಮಗೆ ಅನ್ಬೋದು, ಸರ್ ನಾ ಇದೈತಲ್ಲ ಇದನ್ನು ಇನ್ನೊಂದು ಥರ ಹಿಂಗೆ ಬರಿತೇನೆ, ನಾನು ಈ ಥರ ಚೇಂಜ್ ಮಾಡ್ತೇನೆ, ಅವಾಗ ಇದಕ್ಕೆ 1 2 3 ಅಥವಾ ಇದಕ್ಕೆ 1 2 3. ಇಸ್ ದೇರ್ ಎನಿ ಚೇಂಜ್? ಐಸೋಮರ್ ಬರೋಕ್ಕೆ ಇಲ್ಲಿ ಕೂಡ ಚಾನ್ಸ್ ಆಗ್ತದನ? ಆಗೋದಿಲ್ಲ. ಯಾಕಂದರೆ ಚೇನನ್ನು ಬೆಂಡ್ ಮಾಡಿಟ್ಟಂಗೆ ಆಕೈತಿ, ಅಥವಾ ಕಂಪೌಂಡ್ ಸ್ಟ್ರಕ್ಚರನ್ನು ನೀವು ಬೇರೆ ಕಡೆ ರೊಟೇಟ್ ಮಾಡಿದಾಗ ಇಟ್ಟಂಗೆ ಆಕೈತಿ, ಹೌದಾ? ಎಸ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಒನ್ ಥಿಂಗ್ ಯು ರಿಮೆಂಬರ್, ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಅಲ್ಕೇನ್ಸ್ ಬ್ರಾಂಚಿಂಗ್ ಈಸ್ ನಾಟ್ ಪಾಸಿಬಲ್ ವಿತ್ ಕಾರ್ಬನ್ 1 2 and 3. means minimum 4 number of carbon atoms are required to show chain isomerism especially. ಎಸ್, ಮೀನ್ಸ್ ಇದರ ಅರ್ಥ ಏನಂದರೆ, ನಾವು ಅಲ್ಕೇನ್ಸ್ದಲ್ಲಿ ಐಸೋಮರ್ಸನ್ನು ಬರೀಬೇಕು ಅಂದರೆ ಕಂಪಲ್ಸರಿಯಾಗಿ 4 ಕಾರ್ಬನ್ ಆಟಮ್ ಬೇಕೇ ಬೇಕು. ಇಸ್ ಇಟ್ ರೈಟ್? ಎಸ್, ದೇರ್ ಫೋರ್ ದ ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ಫಾರ್ ದಿಸ್ ಕ್ವಶನ್ ಈಸ್ ಆಪ್ಷನ್ ಡಿ. 4 carbon atoms required for write the isomers. Okay students, next question number 15. 15ನೇ ಕ್ವಶನ್ ನೋಡೋಣ. ಇವಾಗ ಏನಿದೆ ಇಲ್ಲದು, ದ ನಂಬರ್ ಆಫ್ ಪಾಸಿಬಲ್ ಅಲ್ಕೈನ್ಸ್ ವಿತ್ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ C5H8. ಇಲ್ಲಿ ನೋಡ್ರಿ, ನಿಮ್ಗೆ ಕ್ವಶನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಪಾಸಿಬಲ್ ಅಲ್ಕೈನ್ಸ್, ಎಷ್ಟು ಅಲ್ಕೈನ್ಸನ್ನು ಬರೀಬಹುದು, ಎಷ್ಟು ಅಲ್ಕೈನ್ಗಳನ್ನು ಬರೀಬಹುದು, ಏನದು ಕಂಪೌಂಡು ಒಳಗೊಂಡಿರ್ತಕ್ಕಂಥ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ C5H8. The number of possible alkynes with molecular formula C5H8. Yes, students, you know one normal structure. I write here one compound structure. C5H8 means it is pentyne. Is it right? Yes. Therefore, I take 5 carbon atoms. 3, 4, 5. Yes. I write here and here CH2. Here also CH2 and here also CS3. Yes. ಇಲ್ಲಿ ಟ್ರಿಬಲ್ ಬಾಂಡ್ ಅದ ಅಂದರೆ ಇದೊಂದು ಅಲ್ಕೈನ್ ಆಯಿತು. C5 ಅದಾವ H8 3 4 5 6 7 ಇಲ್ಲೊಂದು 8 ಆಯಿತಾ. ಹಾಗಾದರೆ C5H8 ಫಾರ್ಮುಲಾ ಒಳಗೊಂಡದ. ಇದು ಒಂದು ಐಸೋಮರ್ ಆಯಿತು. ನೆಕ್ಸ್ಟು ಅನದರ್ ಐಸೋಮರ್. ಇಲ್ಲಿ ಸ್ವಲ್ಪ ಚೇಂಜ್ ಮಾಡ್ತೇನೆ ನೋಡ್ರಿ. CH3 2 ತೊಗೊಂಡ್ಬಿಡ್ತೇನೆ ಇಲ್ಲೇ. ಅಂದರೆ ಇದನ್ನ ಎದಕ್ಕೆ ಅಟ್ಯಾಚ್ ಮಾಡ್ತೇನೆ ನಾನು ಇಲ್ಲೇ ಒಂದು CHಗೆ ಅಟ್ಯಾಚ್ ಮಾಡ್ತೇನೆ. ಹೌದಾ? ಎಸ್. ಆ್ಯಂಡ್ ಹಿಯರ್ one carbon atom containing triple bond CH. ಈಗ ನೋಡ್ರಿ ಇದನ್ನಿಲ್ಲಿ ಹೌದಾ. ಓಕೆ, ಈಗ ಈ ಕಂಪೌಂಡಲ್ಲಿ ಇಲ್ಲಿ ಕೂಡ ಏನದ ನೋಡ್ರಿ 6 7 8 ಹೈಡ್ರೋಜನ್ ಅದಾವ. ಹೌದಾ. ನೆಕ್ಸ್ಟು ಎಸ್, if you confuse about this question, you write the structure once again like this. Here I write CH, here one CS3, here one CS3, means CS3 2 groups are written here only, and here C triple bond CH. Is it right? Yes. Now the number of hydrogen 3 plus 3 6 7 and this one is 8, and number of carbon atoms 1 2 3 4 5. Yes, it also follows C5H8 formula. Next, third another one structure. Third one I write here CS3 CH2 C. I write double bond in the second carbon atom position as here C. Okay, now CS3. Is it right? Yet it also follows, observe carefully, it also follows the molecular formula C5H8 or not. Yes, 3 5 6 7 8. Yes, 3 plus 3 6 plus 2 8. Okay, number of 5 carbon atoms is present. Okay, therefore try another structure which contain the molecular formula C5H8, then that structure also becomes same to that of these 3 particular structures. ನಿಮಗೆ ಇದನ್ನು ಬಿಟ್ಟು ಬೇರೆ ಏನಾರ ಬರೆಯಕ್ಕೆ ಹೋಗಿ ಟ್ರೈ ಮಾಡಿರಿ, ಸರ್ ನಾ ಹಿಂಗೆ ಬರಿತೇನೆ ರೀ ಅಂತೇಳಿ. ಆ ಒಂದು ನೀವೇನು ಬರೀತಿರಲ್ಲ ಸ್ಟ್ರಕ್ಚರು, ಆ ಸ್ಟ್ರಕ್ಚರು ಈಗ ನಾ ಇಲ್ಲಿ ಏನು 3 ಸ್ಟ್ರಕ್ಚರ್ ಬರ್ದೇನೆ ಅದೇ ಸ್ಟ್ರಕ್ಚರಲ್ಲಿ ಒಂದು ಆಗಿರ್ತದೆ, ಅಥವಾ ಅದನ್ನ ಏನು ಮಾಡಿಟ್ಟಿರ್ಬೋದು ನೀವು ಉಲ್ಟಾ ಮಾಡಿಟ್ಟಿರ್ಬೋದು. ಎಸ್, therefore the number of possible alkynes with molecular formula C5H8 is only 3. Yes, the correct option is option B. Okay students, next question number 19. One of the theoretical question is present here. Observe carefully. An organic compound will show optical isomerism if, okay, what are the conditions for showing the compound to be optically active? Option A, 4 groups attached to carbon atom are different. Option B, 3 groups attached to carbon atom are different. Option C, 2 groups attached to carbon atoms are different. Option D, all the groups attached to carbon atom are same. Okay students, remember one thing. If the compound should be show the optical isomerism, then it must and should contain a symmetric carbon atom. ನಾವು ಹೇಳಿರ್ತೇವೆ ಯೂಶುವಲಿ ಇದ್ರ ಬಗ್ಗೆ ನೀವು ಸೆಕೆಂಡ್ ಇಯರ್ ಒಳಗೆ ಚೆನ್ನಾಗಿ ಕಲಿತೀರಾ. ಹೌದಾ. ಅಲ್ಲಿ ಹೇಳಿರ್ತೇವೆ ಏನಂತ, ಈಗ ಒಂದು ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡು ಆಪ್ಟಿಕಲ್ ಐಸೋಮೆರಿಸಮ್ ತೋರಿಸ್ಬೇಕಾಗಿತ್ತಂದ್ರೆ ಆ ಕಂಪೌಂಡ್ ಒಳಗೆ ಮಸ್ಟ್ ಆ್ಯಂಡ್ ಶುಡ್ ಏನಿರ್ಬೇಕಂತ, ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಆ್ಯಟಮ್ ಇರಬೇಕಂತ. ಹಾಗಾದ್ರೆ ಈಗ ಸರ್ ಏನು ರೀ ಇದು ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಆ್ಯಟಮು? ನಿಮಗೆ ನಾ ಹೇಳಿರ್ಬೋದು, ಒಂದು ಕಾರ್ಬನ್ ಆ್ಯಟಮ್ ಸುತ್ತ ಏನಿರ್ಬೇಕು, ಅದಕ್ಕೆ 4 ಬೇರೆ ಬೇರೆ ಚಂದನ್ನು ಗುಂಪು ಇರಬೇಕು. ಅಂಥವಕ್ಕೆ ಏನಂತೆ ಅಂದರೆ ಆ ಕಾರ್ಬನ್ ಆ್ಯಟಮ್ಗೆ ಕೈರಲ್ ಕಾರ್ಬನ್ ಆ್ಯಟಮ್ ಅಥವಾ ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಆ್ಯಟಮ್ ಅಂತ ಕರಿತೇವೆ. ಯಾವುದು ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಆ್ಯಟಮ್ ಒಳಗೊಂಡಿರ್ತದೆ ಅದೇನಾಗ್ತದೆ, ಆಪ್ಟಿಕಲ್ ಐಸೋಮೆರಿಸಮ್ ತೋರಿಸ್ತಿರ್ತದೆ. ಅದಕ್ಕಾಗಿ ನಾವಿಲ್ಲಿ ಅದಕ್ಕೆ ರಿಲೇಟೆಡ್ ಇರ್ತಕ್ಕಂಥ ಪಾಯಿಂಟನ್ನು ನೋಡಿದರೆ ಏನಿರ್ತದೆ, 4 ಗ್ರೂಪ್ಸ್ ಅಟ್ಯಾಚ್ ಟು ದ ಕಾರ್ಬನ್ ಆ್ಯಟಮ್ಸ್ ಆರ್ ಡಿಫ್ರೆಂಟ್ ಅಂತಕ್ಕಂಥದ್ದು ಆಪ್ಷನ್ ಎ ಕೊಟ್ಟಾರ. ಹೌದಾ. ಸ್ಟೂಡೆಂಟ್ಸ್ ರಿಮೆಂಬರ್, ದ ಕಂಪೌಂಡ್ ವಿಚ್ ಇಸ್ ಶೋಸ್ the optical isomerism, then it must contain a symmetric carbon atom. This carbon atom is also called as chiral carbon atom. Is it right? Yes, therefore the correct answer for this question is option A. Four groups which is attached to a carbon atom are different. Means so that type of carbon atom is called as chiral carbon atom or asymmetric carbon atom. Okay, students, next question number 20. Which of the following molecules contain asymmetric carbon atom? Which of the following molecule contain asymmetric carbon atom? ನಮ್ಗೆ ಹೇಳಿರಿ ಗೊತ್ತದ ನಿಮ್ಗೆ ಅಸಿಮೆಟ್ರಿಕ್ ಅಂದ್ರೆ ಎಂಥದಂತೇಳಿ. ಈಗ ಯಾವ ಕಂಪೌಂಡು ಈಗೇನು ಆಪ್ಷನ್ ಕೊಟ್ಟಿರಲ್ಲ ಅದ್ರಾಗ ಯಾವುದ್ರಾಗ ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಐತಿಪ್ಪ ಅಂತ ಕೇಳ್ಯಾರ. ಈಗ ಒಂದೇ ಸ್ಟ್ರಕ್ಚರ್ ನೋಡೋಣ ಏನೇನದಾವ ಇಲ್ಲಿ. ಇಲ್ಲಿ ಮ್ಯಾಗ ಬರಿತೇನೆ ಸ್ಟ್ರಕ್ಚರ್ ನೋಡ್ರಿ. CH3 ಈ ಒಂದು CH ಕೊಟ್ಟಾನ ಇಲ್ಲಿ ಮಿಡಲ್, CH ಹಿಂಗೆ ಬರ್ಕೊತೀನಿ. ಮ್ಯಾಲ ಒಂದು ಈ ಕಡೆ ಏನೈತಿ CH3 ಐತಿ, ಆಮ್ಯಾಗ ಒಂದು ಕಡೆ CH Cl ಅದ ಒಂದು ಕಡೆ, ಆಮೇಲೆ ಒಂದು ಕಡೆ COOH ಅದ. ಓಕೆ, ಇಲ್ಲಿ ನೋಡ್ರಿ ಇದೇ ಸ್ಟ್ರಕ್ಚರನ್ನು ಬರ್ತೇನೆ ನಾನು. ಒಂದು ಕಾರ್ಬನ್ ಆಟಮ್, ಈ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ CH3 ಒಂದು, H ಒಂದು, Cl ಒಂದು, COH ಒಂದು ಅಟ್ಯಾಚ್ ಆಗಿದ್ದು ಇಲ್ಲಿ ಕಂಡು ಬರಾಕತ್ತದ. ಹಾಗಾದರೆ ಇದಕ್ಕೆ ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಂತ ಕರಿತೀರೋ ಇಲ್ಲೋ ನೀವು? ಎಸ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ವೆನ್ ಯು ಅಬ್ಸರ್ವ್ ದ ಗಿವನ್ ಆಪ್ಷನ್ ಎ, that structure in that the carbon atom contains four different sources. One is hydrogen, one is CH3, one is Cl, one is COH. Then definitely it is an asymmetric carbon atom. ಇಂಥ ಕಂಪೌಂಡ್ಸ್ ಹಂಗಾರೆ ಏನು ಮಾಡ್ತದಂತ? ಆಪ್ಟಿಕಲ್ ಐಸೋಮೆರಿಸಮ್ ತೋರಿಸ್ತದಂತ. Is that right? Yes. Next, if you try another one, here CH3, CH2, COH. ಈಗ ಇದನ್ನು ನೋಡ್ರಿ, ಇದನ್ನ ಸ್ಟ್ರಕ್ಚರ್ ಹಿಂಗೆ ಬರೆದ್ರೆ ನಾನು ಒಂದು ಕಡೆ ಏನೈತಿ CH3 ಐತಿ, ಒಂದು ಕಡೆ CH2 ಅಂದ್ರೆ 2 H ಅದಾವು, ಇಲ್ಲಿ COH ಐತಿ. ಈಗ ಇದಕ್ಕೆ ಏನಂತೀರಿ ನೋಡ್ರಿ, ಇದಕ್ಕೆ ಅನ್ನಕ್ಕೆ ಬರ್ತದನೇ ಈಗ. ಯಾಕಂದರೆ ಇಟ್ ಈಸ್ ನಾಟ್ ಆನ್ ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಬಿಕಾಸ್ ವೆನ್ ಯು ಅಬ್ಸರ್ವ್ ದಿಸ್ ಸ್ಟ್ರಕ್ಚರ್ ಕೇರ್ಫುಲಿ ಇಟ್ ಕಂಟೇನ್ಸ್ ಟೂ ಸಿಮಿಲರ್ ಗ್ರೂಪ್ಸ್. ವಾಟ್ ಆರ್ ದೋಸ್? ಟೂ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್. ಎಸ್, ದಿಸ್ ಟೈಪ್ ಆಫ್ ಕಂಪೌಂಡ್ಸ್ ನಾಟ್ ಶೋಸ್ ಎನಿ ಆಪ್ಟಿಕಲ್ ಐಸೋಮೆರಿಸಮ್. ಈಗ ಇದನ್ನು ಬರೆದು ನೋಡ್ರಿ, ನಿಮಗೆ ಐಡಿಯಾ ಬರ್ತದ. ಈಗ ನನಗಂತ್ರಿ ಆನ್ಸರ್ ಸಿಕ್ಕದಲ್ವಾ? ಯಾಕಂದರೆ ಫಸ್ಟ್ ಸ್ಟ್ರಕ್ಚರ್ನೊಳಗೆ ನನಗೇನು ಸಿಕ್ಬಿಟ್ಟದ? ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಸಿಕ್ಕದ. ಇದನ್ನು ಉಳಿದಿದ್ದು ಆಪ್ಷನ್ ಸಿ, ಆಪ್ಷನ್ ಡಿ ನೀವು ಚೆಕ್ ಮಾಡಿರಿ, ಅದರೊಳಗೆ ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಕಂಡು ಬರ್ತೋ ಏನಿಲ್ಲೋ ಚೆಕ್ ಮಾಡಿರಿ. ಎಸ್, ದೇರ್ಫೋರ್ ದ ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ಫಾರ್ ದ 20 ಕ್ವಶನ್ ಈಸ್ ಆಪ್ಷನ್ ಎ. ಸ್ಟೂಡೆಂಟ್ಸ್, ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನಂಬರ್ 27. Consider the following statements. A hydrocarbon of molecular formula C5H10 is A. Yes, observe carefully. It is also one of the theoretical question. Consider the following statements. A hydrocarbon of molecular formula C5H10 is. C5H10 ಗೆ ಸಂಬಂಧಿಸಿದಂತೆ ಕೆಲವೊಂದಿಷ್ಟು ಪಾಯಿಂಟ್ಸ್ ಕೊಟ್ಟರ, ಅವನು ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಮೊದಲು ಏನು ಒಂದೇದು ಹೇಳ್ತಾರ, ಮೋನೋ ಸಬ್ಸ್ಟಿಟ್ಯೂಟೆಡ್ ಅಲ್ಕೀನ್. ಇದೇನಂತಿದು? ಒಂದು ಮೋನೋ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಅಲ್ಕೀನ್ ಅಂತ ಹೇಳ್ತಾನೆ. Second one, disubstituted alkene. Third one, trisubstituted alkene. Which of the following statements are correct or is correct? Options are given 1, 2, 3. 3 ಕರೆಕ್ಟ್ ಅದಾವ ಅಂತ ಹೇಳ್ತಾರೆ. ಆಪ್ಷನ್ ಬಿ 1ನೇದು 2ನೇದು ಕರೆಕ್ಟ್ ಅದಾವ ಅಂತ ಹೇಳ್ತಾರೆ. ಆಪ್ಷನ್ ಸಿ 2ನೇದು 3ನೇದು ಕರೆಕ್ಟ್ ಅದಾವ ಅಂತ ಹೇಳ್ತಾರೆ. ಆಪ್ಷನ್ ಡಿ 1 and 3 is correct. Students, okay, carefully observe. I write some structures of the compound containing C5H10 molecular formula here. I write the structure as CH3, CH2, CH2, CH, double bond CH2. Yes, observe whether this compound contain the molecular formula C5H10 and it is, remember, it is also one of the alkene. Okay, double bond contain means it is one of the alkene. It contains 1, 2, 3, 4, 5 carbon atoms. 3, 2, 5, 7, 8, 10 means 10 hydrogen atoms. Okay, here only one double bond is present. Is it right? Yes, first carbon atom containing double bond here. Therefore, this is an example for mono substituted. This is an example for mono substituted. ಯಾಕಂದ್ರೆ ಯೂಸ್ವಲಿ ಇಲ್ಲಿ ಸಿಂಗಲ್ ಬಾಂಡ್ ಇಲ್ಲಿ ಏನಿರ್ತಿತ್ತು, H2 ಅಂತ ಇರ್ತಿತ್ತು. ಅವಾಗ ಏನಾಗಿದೆ, ಇಲ್ಲಿ ಒಂದು H ರಿಪ್ಲೇಸ್ ಆದಂಗೆ ಆಯಿತು. ಹೌದಾ? ಓಕೆ, ನೆಕ್ಸ್ಟು ಅನದರ್ ಸ್ಟ್ರಕ್ಚರ್ ಬರೀತೇನೆ ಇಲ್ಲಿ. ಹಿಯರ್ CH3, CH, ಡಬಲ್ ಬಾಂಡ್ CH, ಸಿಂಗಲ್ ಬಾಂಡ್ CH2, ಸಿಂಗಲ್ ಬಾಂಡ್ CH3. ಈಗ ಈ ಸ್ಟ್ರಕ್ಚರ್ನ ನೋಡ್ರಿ, ಸೆಕೆಂಡ್ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ಹೌದಾ? ಸೆಕೆಂಡ್ ಕಾರ್ಬನ್ ಐಟಮ್ಗೆ ಏನು ಬರ್ದ ನಾನು ಈಗ ಇಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀರಿ, ಅವಾಗ ಇಲ್ಲಿಂದ ನಿಯರ್ ಆಗ್ತದಲ್ವಾ, 1 2 ಅಂತ ಬರ್ದಿರ್ತೀರಿ. ಸೆಕೆಂಡ್ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ಡಬಲ್ ಬಾಂಡ್ ಅದ ಇಲ್ಲಿ. ಹೌದಾ? ಈಗ ನೋಡ್ರಿ, ಇಲ್ಲಿದು ಒಂದು ಎಚ್ ರಿಮೂವ್ ಆಗೈತಿ, ಇಲ್ಲಿದು ಒಂದು ಎಚ್ ರಿಮೂವ್ ಆದಂಗೆ ಆಯಿತು. ಹಾಗಾದರೆ ಇಲ್ಲಿ ಬೈ ಸಬ್ಸ್ಟಿಟ್ಯೂಟೆಡ್ ಅಥವಾ ಡೈ ಸಬ್ಸ್ಟಿಟ್ಯೂಟೆಡ್ ಅಂತ ಹೇಳ್ಬೋದು. ಇಲ್ಲಿ ಡೈ ಸಬ್ಸ್ಟಿಟ್ಯೂಟೆಡ್ ಅಲ್ಕೀನ್, ಡೈ ಸಬ್ಸ್ಟಿಟ್ಯೂಟೆಡ್ ಅಲ್ಕೀನ್. ನೆಕ್ಸ್ಟ್ ಸರ್ ಇದನ್ನು ಹಿಂಗೂ ಬರಿಬೋದಲ್ರಿ ಹೆಂಗಾರ ಅಂತ ಅನ್ಬೋದು ನೀವು. ಈಗ ನಿಮಗೆ ತಲೆಯೊಳಗೆ ಬರ್ತಿರ್ತದೆ ಇನ್ನೊಂದು ಸ್ಟ್ರಕ್ಚರ್ ಯಾವ ಥರ, ನಾ ಇಲ್ಲಿ ಬರಿತೇನೆ ನೋಡ್ರಿ. CS3 ಸಿಂಗಲ್ ಬಾಂಡ್ ಸಿ, ಇಲ್ಲೇ CS3 ಡಬಲ್ ಬಾಂಡ್ ಹಾಕಿಬಿಡ್ತಾನೆ ಇಲ್ಲಿ. ಹೌದಾ? ಡಬಲ್ ಬಾಂಡ್ CS3. ಎಸ್, ಇದು ಅದು ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಸೇಮ್ ಐತಿ ನೋಡ್ಕೊಡ್ರಿ ಒಂದ್ಸಲ. 1 2 3 4 5 ಕಾರ್ಬನ್ ಐಟಮ್ಸ್, 3 4 4 3 7 7 3 10. ಸೊ ಟೋಟಲ್ 5 ಕಾರ್ಬನ್ ಐಟಮ್, 10 ಹೈಡ್ರೋಜನ್ ಐಟಮ್ ಅದಾವೆ. ಹೌದಾ? ಎಸ್, ಈಗ ನೋಡ್ರಿ ಇಲ್ಲಿ ಎಷ್ಟು ಹೈಡ್ರೋಜನ್ ರಿಪ್ಲೇಸ್ ಆಗ್ಯಾವು. ಇಲ್ಲಿ ನೋಡ್ರಿ CH2 ಇರ್ತೈತೆ ಅಂತ ಹೇಳ್ತಿದ್ರಿ ಅಲ್ಲಿ ಬಾಂಡ್ ಇನ್ವಾಲ್ವ್ ಆದಾಗ 2. ಹೌದಾ? ಇಲ್ಲಿದು 1 ಅಂದರೆ ಟೋಟಲ್ 3 ಹೈಡ್ರೋಜನ್. 3 ಕಡೆ ಏನಾಗ್ಯದ, ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಆಗ್ಯದ. ಹಾಗಾದರೆ ಇಟ್ ಈಸ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಟ್ರೈ ಸಬ್ಸ್ಟಿಟ್ಯೂಟೆಡ್ alkene. Try substituted alkene. Okay students, therefore the correct answer for the question is consider the following statements. Hydrocarbon molecular formula C5H10. Which of the following statements are correct? 1 2 3 all statements are correct. Therefore the correct answer for this question is option A. Is it right? Yes. Okay students, next question number 30. 30ನೇ ಕ್ವಶನ್ ಅನ್ನು ನೋಡೋಣ. ಇವಾಗ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ. ವಿಚ್ ಆಫ್ ದ ಫಾಲೋಯಿಂಗ್ ಕಂಪೌಂಡ್ಸ್ ಈಸ್ ಐಸೋಮೆರಿಕ್ ವಿತ್ 2244 ಟೆಟ್ರಾಮಿಥೈಲ್ ಹೆಕ್ಸೇನ್. ಇಲ್ಲೊಂದು ಕಂಪೌಂಡ್ ಕೊಟ್ಬಿಟ್ಟಾರ್ರಿ ಅವರು. ಯಾವುದದು? 2244 4 ಕೊಟ್ಟ ಮಿಥೈಲ್ ಗ್ರೂಪ್ ಅದಾವ, ಹೆಕ್ಸೇನ್ ಅದ. 2244 ಟೆಟ್ರಾಮಿಥೈಲ್ ಹೆಕ್ಸೇನ್. ಈಗ ಕೊಟ್ಟಂಥ ಆಪ್ಷನ್ದೊಳಗೆ ಯಾವ್ದು ಐಸೋಮರ್ ಆಗ್ತದೆ ಅದಕ್ಕೆ? ಆಪ್ಷನ್ ಎ 3 ethyl 2 dimethyl pentane, option B 4 isopropyl heptane, option C 4 ethyl 3 methyl 4N propyl octane, and option D 4 diethyl 3 methyl heptane. Yes students, observe carefully. What is the structure? 2244 tetramethyl hexane. Yes students, first you write the structure of 2244 tetramethyl hexane. I write here. Okay, this is CS3 and here C, and second carbon atom contain 2 methyl group, means 2 comma 2 CS3s. Okay, and here this one is CS3. Okay, here I write only HH, and here I write C. This carbon atom means 4 carbon atom also contain 2 CS3 groups, and here CH2 CH3. Okay, total number of carbon atoms 6 here in the parent chain. Is it right? 1 2 3 4 5 6. Okay, as the 2244 tetramethyl hexane structure I written here, and when you observe this, it contains total carbon atoms, means molecular formula. ಇಲ್ಲಿ 6, ಇದು 7 8 9 10. Okay, carbon atoms are C10. Next, molecular formula H12. Is it right? Yes, because alkane single bond is present, then it follows CnH2n plus 2 formula. Therefore directly I write C10H12, sorry, H22. Is it right? Yes. Now molecular formula of the given compound is C10H22. Among the given options, which one has this molecular formula? That is the isomer. Okay students, you must write all the structures of the given compound. Okay students, when you observe all the given option structure, the structure of the compound which is given in B option, I think it follows the same molecular formula, that is C10H22, because what is that? 4 isopropyl heptane. Okay, I write the structure like this: 4 isopropyl heptane, 4 isopropyl heptane. I write the structure like this. Observe carefully. Here one single bond. Here. Okay. Okay. Observe here. Students, you know number of carbon atoms here. Okay. Here CH3 is present. Here CH2 is present. Here also CH2. And here it contains 3 bond means only CH is present. Here also CH and here CS3. CS3. Is it right? As here CH2, here also CH2, and here CH3. Is it right? Yes. This is the structure of 4 isopropyl heptane, because in the parent chain, if you observe here, this one is first carbon atom, second, third, fourth, 5, 6, 7. 7 carbon atoms, and fourth carbon atom contain isopropyl group. Yes, this one is the fourth carbon atom. If you start the numbering from here, 1, 2, this one is 3, and this one is 4, this one is 5, this one is 6, and this one is 7. Therefore, the name ends with heptane. Is it right? Yes, another important point. Fourth carbon atom contain isopropyl group. One side CH, here CH3, CH3. Okay, this one is isopropyl. Isopropyl. One of the carbon atom means last but one carbon atom contain two CH3 group, then it is called isoform. ಈಗ ನೋಡ್ರಿ ಇದನ್ನು ಬಿಟ್ಟರೆ ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಎರಡು CH3 ಒಳಗೊಂಡಿರಬೇಕು ಅಂತ, ಅದಕ್ಕೆ ನಾವೇನಂತೇವೆ ಐಸೋ ಅಂತ ಕರಿತೇವೆ. ಓಕೆ students, when you observe molecular formula of this compound also, it follows C10H22. Therefore, the correct isomer of 2244 tetramethyl hexane is 4-isopropyl heptane. Therefore, the correct option is option B. Okay students, next question number 32. Which of the following compounds will show metamerism? Okay students, before going to the options, first to recall the points which are related to metamerism. Students, when you observe the given options, first you remember one thing. Metamerism is possible in ethers, thioethers, secondary amines, ketones, and thioethers. Students, this metamerism is also appears in presence of secondary amines, ketones, esters. Metamers belongs to the same family but differs in the nature of alkyl group. Yes, if you know this point, then the correct answer for this question is option B. Option B. Why? Students, remember, if you take an example, this one C2H5, yes, C2H5, it is an example for diethyl thioether. It is an example for diethyl thioether. This one is also written as CS3HCH2. Is it right? CS3HC2, sorry, HCH2. This is this compound name is methyl propyl thioether. Methyl propyl thioether. Okay students, therefore the option B is right answer because it shows metamerism. Is it right? Yes. ಏನ್ರಿ ಮೆಟಾಮೆರಿಸಮ್ ಅಂದರೆ ನಿಮ್ಗೆ ಗೊತ್ತದ, ಸರಿ, SCH2. ಓಕೆ, ಏನು ಮೆಟಾಮರ್ಸ್ ಅಂದರೆ ಒಂದು ಅಲ್ಕೈಲ್ ಗ್ರೂಪ್ಸು, ಫಂಕ್ಷನ್ ಗ್ರೂಪ್ ಪಕ್ಕದಲ್ಲಿರ್ತಕ್ಕಂಥ ಅಲ್ಕೈಲ್ ಗ್ರೂಪ್ಸ್ ಏನಾಗಬೇಕು, ಡಿಫ್ರೆಂಟ್ ಆಗಿ ಕಂಡು ಬರಬೇಕು ಅಲ್ವಾ, ಅದೇ ಈ ಥರ ಕಂಡು ಬರ್ತದೆ. ಎಸ್, ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನಂಬರ್ 36 ಸ್ಟೂಡೆಂಟ್ಸ್. ವಾಟ್ ಈಸ್ ದ ಕ್ವಶನ್? ಅಬ್ಸರ್ವ್ ದ ಗಿವನ್ ಕ್ವಶನ್ಸ್ ಕೇರ್ಫುಲಿ. Here two isomers are given, C6H5C triple bond N, C6H5N triple bond C are which type of isomers? Okay, given options are position, option B functional, option C tautomerism, and option C linkage isomers. Students, remember, when you observe the given isomers, it contains one side C triple bond N. Is it right? Yes. Here one side C triple bond N group is present. In another one, there is a N triple bond C is present. Yes, this one is cyanide group. This one is cyanide functional group, and this one is isocyanide group. Is it right? Yes, students, remember, C triple bond is cyanide group and N triple bond C means it indicates isocyanide group. There are two functional groups present in the isomers. Therefore, functional isomerism is exhibited by this type of isomers. Yes, option B is the right answer. ಸ್ವಲ್ಪ ಇದನ್ನ ನೆನ್ಪಿಡಿ, ಒಂದೆರಡು ಸಲ ಇದನ್ನು ಕೇಳಿದ್ದಾರೆ. ಏನಿಲ್ಲ, ಅಲ್ಲಿ ಸಿ ಎನ್ ಅನ್ನೋದು ಸೈನೈಡ್ ಗ್ರೂಪು, ಎನ್ ಸಿ ಅನ್ನೋದು ಐಸೋಸೈನೈಡ್ ಗ್ರೂಪ್ ಆಗಿ ಕಂಡು ಬರ್ತಿರ್ತದೆ. ಇಲ್ಲಿ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಏನಾಗ್ತದೆ, ಡಿಫ್ರೆಂಟ್ ಅದ, ಒಂದು ಸೈನೈಡ್ ಅದ, ಇನ್ನೊಂದು ಐಸೋಸೈನೈಡ್ ಅದ, ಅದಕ್ಕಾಗಿ ಫಂಕ್ಷನಲ್ ಐಸೋಮರ್ಸ್ ಅಂತ ಹೇಳ್ಬೋದು. ಸ್ಟೂಡೆಂಟ್ಸ್, ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನಂಬರ್ 44. ವಿಚ್ ಈಸ್ ಎ ಪೇರ್ ಆಫ್ ಜಿಯೋಮೆಟ್ರಿಕಲ್ ಐಸೋಮರ್ಸ್? ವಿಚ್ ಈಸ್ ಎ ಪೇರ್ ಆಫ್ ಜಿಯೋಮೆಟ್ರಿಕಲ್ ಐಸೋಮರ್ಸ್? Four structures are given. Among those, 1 and 2 are geometrical isomers, 1 and 3 are geometrical isomers, second one, third one and fourth one are geometrical isomers, second one and fourth one are geometrical isomers. Okay students, what is your answer? Which is the pair of geometrical isomers? Geometrical isomers ಅಂದ್ರೆ ಏನಿರಬೇಕು ಗೊತ್ತದ ನಮಗೆ, ಏನೇನು ಒಳಗೊಂಡಿರಬೇಕು, ಡಬಲ್ ಬಾಂಡ್ ಇರಬೇಕು ಅಂತ ಗೊತ್ತದ. ಆಮೇಲೆ ಆ ಕಾರ್ಬನ್ ಆಟಮ್ ಸುತ್ತ ಇರ್ತಕ್ಕಂಥ ಆಟಮ್ಸ್ ಏನಿರ್ತಾವ ಅವು ಡಿಫ್ರೆಂಟ್ ಆಗಿರಬೇಕು ಅಂತ ಗೊತ್ತದ, ಹೌದಾ? ಹಾಗಾದರೆ ವೆನ್ ಯು ಅಬ್ಸರ್ವ್ ದ ಫಸ್ಟ್ ಸ್ಟ್ರಕ್ಚರ್, ಇಸ್ ಇಟ್ ರೈಟ್? ಎಸ್, ಇಫ್ ಯು ಅಬ್ಸರ್ವ್ ದ ಫಸ್ಟ್ ಸ್ಟ್ರಕ್ಚರ್, here this carbon atom. Okay students, when you observe the first structure of this carbon atom contain two similar groups Br. In this type of compounds, geometrical isomerism is not possible. Is it right? Yes. Next, come to the second structure. Here double bond is present. Here Br, CS3, ClH. Okay, it is also, it shows geometrical isomers. Next, if you come to the point of third structure, it also contain four different groups. It also shows geometrical isomerism. Here four groups are different, therefore it also shows geometrical isomerism. Then your answer, second one, third one and fourth one shows geometrical isomerism. Students, remember, what are the conditions for geometrical isomerism? Two groups must be different on left hand end of the bond and two different groups on the right hand end. Is it right? Yes, therefore second one, third one and fourth one show geometrical isomerism. Therefore correct answer is option C. Students, next question number 60. How many optically active stereoisomers are possible for butane 2,3-diol? How many optically active stereoisomers are possible for 2,3-diol, butane 2,3-diol? Okay. Students, first I write the structure of butane 2,3-diol here, 2,3-diol. Okay. Here CS3, CH, here OH, and here also OH, and here CS3. Is it right? Yes, students, butane 2,3-diol, it has similar chiral carbon atoms. Means, which is already you studied in presence of tartaric acid. I show the structure. It contains similar atoms containing chiral carbon. Hence, it also have three optical isomers. One is D form, another one is L form, and another one mesoform. Among these two, means D and L, D means dextro and L means Leo, are optically active because it contains a asymmetric carbon atoms. Dextro ಮತ್ತು ಲಿಯೋ ರೊಟೇಟ್ರಿ ನೋಡಿದಾಗ ಅಲ್ಲಿ ಆಪ್ಟಿಕಲಿ ಆ್ಯಕ್ಟಿವ್ ಅಂತ ಹೇಳ್ತೇವೆ, ಯಾಕಂದರೆ ಆ ಸ್ಟ್ರಕ್ಚರಲ್ಲಿ. ಈಗ ನೋಡ್ರಿ, ಈಗಿಲ್ಲೇ ಎ ಸಿ ಅದಪ್ಪ ಇಲ್ಲಿ, ಹೌದಾ? ಓಕೆ, ಈ ಸಿ ಅದ ಇಲ್ಲಿ ಇದಕ್ಕೆ ನಾನು ಸ್ಟಾರ್ ಮಾರ್ಕ್ ಹಾಕ್ತೀನಿ. ಯಾಕೆ ಇದು ಒಂದು OH ಒಳಗೊಂಡದ, ಒಂದು H ಒಳಗೊಂಡದ, ಒಂದು CS ಒಳಗೊಂಡದ, ಒಂದು ಇಂಥ ಗ್ರೂಪ್ ಒಳಗೊಂಡ, ಅಂದರೆ ಡಿಫ್ರೆಂಟ್ ಗ್ರೂಪ್ಸ್ ಇದ್ದಂಗೆ ಆಯಿತು. ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ನೋಡ್ರಿ, ಈ ಕಡೆ ದೊಡ್ಡ ಗ್ರೂಪ್ ಅದ CS3 H OH ಅದ. ಹಾಗಾದರೆ ಇಲ್ಲಿ ನೋಡ್ರಿ, ಬಟ್ ಆಟಮ್ಸ್ ಈ ಕೈರಲ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಒಳಗೊಂಡಿರ್ತಕ್ಕಂಥ ಗ್ರೂಪ್ಸ್ ಏನದಾವು, ಸೇಮ್ ಅದಾವು. ಅದಕ್ಕೆ ಸಿಮೆಟ್ರಿ, ಇದು ಟಾಟಾರಿಕ್ ಆಸಿಡ್ ಅಲ್ಲಿ ತೋರಿಸಿದ್ನಲ್ಲ ಅದೇ ಥರ ಇಲ್ಲಿ ಕೂಡ ಕಂಡು ಬರ್ತದೆ. ಅದಕ್ಕಾಗಿ ನಾನು ಡೈರೆಕ್ಟಾಗಿ ಹೇಳ್ಬೋದು, ಇಲ್ಲಿ D ಫಾರ್ಮ್ ಬರಿಬೋದು, L ಫಾರ್ಮ್ ಬರಿಬೋದು, ನೆಕ್ಸ್ಟ್ ಮಿಸೋ ಫಾರ್ಮ್ ಬರಿಬೋದು. ಬಟ್ ಆಪ್ಟಿಕಲಿ ಆಕ್ಟಿವ್ ಸ್ಟೀರಿಯೋ ಐಸೋಮರ್ಸ್ ಕೇಳಿದಾರಲ್ಲ, ಅದ್ರೊಳಗೆ ಎರಡೇ ಬರ್ತಾವ. ಯಾವುವು? ಒಂದು D ಫಾರ್ಮ್ ಮತ್ತು L ಫಾರ್ಮ್. Students, you remember or recall the points which conditions are applied for optical activity. Remember students, the compound must contain an asymmetrical carbon atom, means chiral carbon atom. Here chiral excess is present. Okay, yes, therefore the correct answer for this question is option B2. One T form and another one L form. Students, next question number 65. Observe the given compound structure. The question is, the given compound will show option A geometrical isomerism, optical isomerism, geometrical and optical isomerism, neither geometrical nor optical isomerism. Which one is the correct answer? Students, when we observe the given structure, the given compound contain double bond. ಈಗ ಈ ಒಂದು ಕಂಪೌಂಡಲ್ಲಿ ನಾವು ಏನು ನೋಡಕತ್ತೀವಿ, ಡಬಲ್ ಬಾಂಡ್ ಅದ ಇದ್ದದ್ದು ಕಾಣಕತ್ತದಲ್ವಾ. ಹಾಗಾದರೆ ಡಬಲ್ ಬಾಂಡ್ ಐತಿ ಅಂದ್ರೆ ಯಾವ್ದು ಕಂಡಿರ್ಬೋದು? ಮತ್ತು ಸುತ್ತ ನೋಡ್ರಿ ಬೇರೆ ಬೇರೆ ಗುಂಪದವನ್ನ ನೋಡ್ರಿ ಅಲ್ಲಿ. ಸ್ಟೂಡೆಂಟ್ಸ್, ದ ಗಿವನ್ ಕಂಪೌಂಡ್ ಕಂಟೈನ್ ಡಬಲ್ ಬಾಂಡ್ ಆ್ಯಂಡ್ ಈಚ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಹ್ಯಾಸ್ 2 ಡಿಫ್ರೆಂಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ಸ್ ಆ್ಯಂಡ್ ಆಪ್ಟಿಕಲ್. ಓಕೆ, ಫಸ್ಟ್ ಯು ಅಬ್ಸರ್ವ್. The double bond containing carbon atoms contain 4 different groups around it. Therefore, it shows geometrical isomerism first. And it shows optical isomerism also, because due to the presence of chiral carbon atom. Due to the presence of chiral carbon atom. ಅಲ್ಲಿ ನೋಡ್ರಿ CH-OH COH ಇದದ ಇಲ್ಲಿ. ಈಗ ಇದಕ್ಕೆ ಅದಕ್ಕೆ ಏನಂತೀರಿ? ಈ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ, ಈ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ಎಂತ ಅದಂತೀರಿ? H ಅದ. ಇಲ್ಲಿ ನಾವು ಈ ಕಡೆ ಒಂದು ದೊಡ್ಡ ಗ್ರೂಪ್ ಅದ, ಇಲ್ಲಿ OH ಅದ, ಇಲ್ಲಿ COH ಅದ. ಇದೇನ್ರಿ? ಇದು ಕೈರಲ್ ಕಾರ್ಬನ್ ಆಟಮ್. ಕೈರಲ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಇತ್ತು ಅಂದ್ರೆ ಏನು ಹೇಳ್ತೇವೆ ನಾವು? ಅದು ಆಪ್ಟಿಕಲ್ ಐಸೋಮೆರಿಸಮ್ ತೋರಿಸ್ತದ ಅಂತ ಹೇಳ್ತೇವೆ. ಹಾಗಾದರೆ ಆನ್ಸರ್ ಯಾವ್ದು ಕೊಡ್ತೀರಿ ಇದಕ್ಕೆ? ದ ಗಿವನ್ ಕಂಪೌಂಡ್ ಶೋಸ್ ಬೋತ್ ಜಿಯೋಮೆಟ್ರಿಕಲ್ ಆ್ಯಂಡ್ ಆಪ್ಟಿಕಲ್ ಐಸೋಮೆರಿಸಮ್ ಅಂತ ಹೇಳ್ಬೋದು. ಓಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನಂಬರ್ 73. ಇನ್ ವಿಚ್ ಆಫ್ ದ ಫಾಲೋಯಿಂಗ್ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಐಸೋಮೆರಿಸಮ್ ಈಸ್ ನಾಟ್ ಪಾಸಿಬಲ್? Yes, it is one of the theoretical questions. You remember this point. In which of the following functional group isomerism is not possible? Before going to the options, first you remember one point related to this question. Students, alkyl halides functional group isomerism. Alkyl halides functional group isomerism is not possible. In alkyl halides, functional group isomerism is not possible. Alcohols and ethers, aldehydes and ketones, cyanides, isocyanides are functional group isomers. Yes, if you know this point, which type of compounds do not show functional isomerism? Alkyl halides. Therefore, the correct answer for this question is option C. ಇಲ್ಲಿ ನಾವು ಹೆಲೈಡ್ಸ್ ತೊಗೊಂಡು ಅದನ್ನು ಫಂಕ್ಷನಲ್ ಐಸೋಮರ್ಸ್ ಅಂತ ಬರೆಯೋಕ್ಕಾಗಂಗಿಲ್ಲ. ClBr ಇವ್ಕೂರ್ನ ಆಧಾರವಾಗಿ ಇಟ್ಕೊಂಡು ಐಸೋಮರ್ಸನ್ನು ಬರೆಯೋಕ್ಕಾಗಂಗಿಲ್ಲ. ಅಲ್ಕಾಲ್ ಹೆಲೈಡ್ಸ್ ಅವು ಐಸೋಮೆರಿಸಮ್ ಅಂದರೆ ಫಂಕ್ಷನಲ್ ಐಸೋಮೆರಿಸಮ್ ತೋರಿಸಂಗಿಲ್ಲ. ಆಲ್ಕೋಹಾಲ್ಸು, ಆಲ್ಡಿಹೈಡ್ಸು, ಸೈನೈಡ್ಸು, ಐಸೋಸೈನೈಡ್ಸು, ಕೀಟೋನ್ಸು ಇಂಥವೆಲ್ಲ ಏನಾಗ್ತಾವ? ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಅದ, ಅವು ತೋರಿಸ್ತಾವೆ ಫಂಕ್ಷನಲ್ ಐಸೋಮೆರಿಸಮ್. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನಂಬರ್ 79 ಸ್ಟೂಡೆಂಟ್ಸ್. ವಾಟ್ ಇಸ್ ದ ಕ್ವಶನ್? ಅಬ್ಸರ್ವ್ ಕೇರ್ಫುಲಿ. ದ ಫಾಲೋಯಿಂಗ್ ಕಂಪೌಂಡ್ಸ್ ಡಿಫರ್ ಇನ್. The following compounds differ in. 2 structures are given here. Option A configuration, option B conformations, option C structures, option D chirality. Yes, usually it is also present in your second year syllabus. First you remember, students, remember, for a compound show optical isomerism. The given compounds here are different from each other in configuration. In 79 question, the given structures are different or differing from each other in configuration because structure 1 cannot change into another without breaking of bonds. Therefore, the correct option is A. Configuration. The different means the two given structures are differed in configuration. ಇಲ್ಲಿ ನೋಡ್ರಿ ಈ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ಸಿ ಎಲ್ ಅದಾವ, ಈ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ಸಿ ಎಲ್ ಎಚ್ ಅದಾವ. ಅಲ್ಲಿ ಕಾನ್ಫಿಗರೇಷನ್ ಏನದ ಚೇಂಜ್ ಆಗಿ ಕಂಡು ಬರಕತ್ತದ. ಇಲ್ಲಿ ಎಚ್ ಸಿ ಎಲ್ ಅದ, ಈ ಕಡೆ ಎಚ್ ಅದ. ಕಾನ್ಫಿಗರೇಷನ್ ಡಿಫ್ರೆಂಟ್ ಅದ. ಓಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ನೆಕ್ಸ್ಟ್ ಮೂವ್ ವಿತ್ ಎಕ್ಸಸೈಸ್ 3 ಫಾಸ್ಟ್ ಕಾಂಪಿಟೇಷನ್ ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸ್ ಕ್ವಶನ್ಸ್. In that, the first one is, out of the following, the alkene that exhibit optical isomerism is. ಓಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ಆಪ್ಟಿಕಲ್ ಐಸೋಮೆರಿಸಮ್ ಅಂತ ಕ್ವಶನ್ ಬಂದತಿ ಅಂದ್ಕೊಳ್ಳಿ ನಮಗೆ ತಲೆಯಾಗ ಏನು ಬರಬೇಕು, ಎಂಥ ಕಂಪೌಂಡ್ಸ್ ಆಪ್ಟಿಕಲ್ ಐಸೋಮೆರಿಸಮ್ ತೋರಿಸ್ತಾವಪ್ಪ. ಸ್ಟೂಡೆಂಟ್ಸ್, ಅಟ್ ದ ಟೈಮ್ ಯು ರಿಮೆಂಬರ್, ಫಾರ್ ಎ ಕಂಪೌಂಡ್ ವಿಚ್ ಶೋಸ್ ಆಪ್ಟಿಕಲ್ ಐಸೋಮೆರಿಸಮ್, ಇಟ್ ಮಸ್ಟ್ ಕಂಟೈನ್ chiral carbon atom. Is one of the necessary condition. Is it right? Yes. Write all the given compound structures carefully, and which one has asymmetric, means chiral carbon atom that must exhibit optical isomerism. Okay students, you write all the structures. I go to directly the structure C here. Okay, what is the structure? 3-methyl 1-pentene. Is it right? Yes. 3-methyl 1-pentene. I write a structure here. CH2, CH, CH, 1H. I write both sides. Here CS3. Sorry, here no H. And here CH2, CS3. Is it right? This one is the 3-methyl pent-1-ene or 1-pentene. 1, 2, 3, 4, 5. Yes, students, this is a structure of 3-methyl 1-pentene. Yes, it contains asymmetric carbon atom or not? Check. Yes, this carbon atom. Here one H is present, one CS3, over here one group, and here one different group. Is it right? Therefore, it shows optical isomerism. If you take first one, I write 3-methyl 2-pentene. I think already you written the structure of this compound. Pentene. Is it right? Therefore, I write 5 carbon atoms. 3, 4, 5. Is it right? Yes. Third carbon atom contain methyl group, and second carbon atom contain double bond. Yes, I write here double bond. Okay, here CS3, and here I write only H, and here there is no. Here CH2, here CS3. Is it right? Yes. 3-methyl. Okay students, when you observe this one, what about this carbon atom? Here it contains 3-methyl pent-2-ene. Is it right? Yes. Here this one is the carbon atom. Here CS2 CS3, and here CH CS3, and here only CS3 is present. Is it right? Then it is not an asymmetric carbon atom. Only 3 groups are present on the carbon atom. Okay, therefore it is optically inactive. Okay, therefore the correct answer for this question is option C, 3-methyl 1-pentene. This compound shows optical isomerism because it contains an asymmetric or chiral carbon atom. Students, next question number 4. Which of the following acids does not exhibit optical isomerism? Which of the following acids does not exhibit optical isomerism? Option A, lactic acid. Option B, tartaric acid. Option C, malic acid. Option D, alpha amino acids. Students, remember, optical isomers contain an asymmetric or chiral carbon atom. You know this point. And what is chiral carbon atom? Which contain 4 means carbon atom which is attached to 4 different groups. When you observe the given compound structures, all the given compounds except malic acid, all except malic acid exhibit optical isomerism, because malic acid structure, it contains the structure, yes, I write the malic acid structure, yes, COOH, here COH, and here H, here C, here H, and here H, and here COH. This is the structure of malic acid. Students, remember the question is which of the following acids does not exhibit optical isomerism? Which type of compound shows optical isomerism? You know, it must contain a symmetric carbon atom. But when you observe this one, if you take this carbon atom, it contains two similar hydrogen groups, therefore it do not contain any asymmetric carbon atom. Therefore, this one is wrong, means malic acid is the right answer for this question because it does not exhibit optical isomerism. And I think in the previous video, you know, tartaric acid structure, it contains two asymmetric carbon atom, then definitely it shows optical isomerism. And in presence of alpha amino acids also asymmetric carbon atom is observed. In presence of lactic acid is also asymmetric carbon atom is observed. Okay students, next question number 6. The number of structural isomers possible from the molecular formula C3H9Nase. The number of structural isomers possible from the molecular formula C3H9Nase. Students, write the number of structural isomers containing molecular formula C3H9N here one by one. You also try to write. Yes, first one CS3, CH2, CH2, NH2. Yes, it follows C3H9N formula, therefore it is one of the isomer. And here CS3, NH, CH2, CS3 ಈ ಥರನೂ ಬರಿಬೋದಲ್ವಾ, ಅದಕ್ಕಾಗಿ ಇದು ನೋಡ್ರಿ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಸೇಮ್ ಅದಲ್ಲ, ನೋಡ್ಕೊತ ಹೋಗ್ರಿ ನೀವು. ಎಸ್, ನೆಕ್ಸ್ಟ್ ಅನದರ್ ಒನ್, ಥರ್ಡ್ ಒನ್ ರೈಟ್ CS3, CH ಇಲ್ಲಿ ಏನು ಮಾಡಿಬಿಡ್ತಾನೆ, ಇದಕ್ಕೆ NH2 ಗ್ರೂಪ್ ಹಾಕ್ತಾನೆ, ಇಲ್ಲೇ CS3 ಬರೀತಾನೆ. ನೆಕ್ಸ್ಟ್ ಅನದರ್ ಸ್ಟ್ರಕ್ಚರ್ CS3, ಒಂದು ಎನ್ ತಗೊಂತಾನೆ, ಇಲ್ಲಿ CS3 ಬರೀತಾನೆ, ಇಲ್ಲಿ CS3 ಬರೀತಾನೆ. ಓಕೆ, there are 4 structures or structural isomers are possible for the molecular formula C3H9N. ಈಗ ನೋಡ್ರಿ ಸರ್, ನಾ ಈ ಥರ ಇನ್ನೊಂದು ಸ್ಟ್ರಕ್ಚರ್ ಈ ಥರ ಬರಿತೇನೆ ಅಂತಂದರೆ, ನಾ ಈಗ ಇಲ್ಲಿ ಏನು 4 ಸ್ಟ್ರಕ್ಚರ್ ಬರ್ದೇನಲ್ಲ, ಅದೇ ಸ್ಟ್ರಕ್ಚರನ್ನು ಹೋಲುವಂಥದ್ದು ಇನ್ನೊಂದು ನೀವು ಬರೆದಿರ್ತೀರಿ. ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಸೇಮ್ ಇತ್ತಂದ್ರೆ ಇದೇ ಸ್ಟ್ರಕ್ಚರ್ ರಿಪೀಟ್ ಆಕೈತೆ ಅಷ್ಟೇ, ಹೌದಾ? ಓಕೆ, therefore the correct answer for this question is option A. Option A means 4 isomers, means structural isomers are possible for the compound containing molecular formula C3H9N. Students, next question number 8. The number of structural isomers for C6H14As. The number of structural isomers for C6H14As. I think you know the formula C6H14. It is an example for alkane because it follows the CnH2n plus 2 formula. Is it right? Yes. Okay, then write the structural isomers. The structural isomers, I write some alkanes related to the molecular formula C6H14 means hexane. Okay, first one 1 2 3 4 5 6, is it right? It is one of the isomer. Next another one, okay, this one 1 2 3 4 5, and this one carbon atom also 6th one. ಓಕೆ, ನೀವು ಅನ್ಬೋದು ಸರ್ ಈ ಥರ ಯಾಕೆ ಬರಿಲ್ರಿ, ನಾ ಈ ಸ್ಟ್ರಕ್ಚರನ್ನು ಈ ಥರ ಬರಿತೇನೆ. ಯಾವ ಥರ? ಈ ಥರ 1 2 3 4 5 ಆ್ಯಂಡ್ ದಿಸ್ ಒನ್ 6. ಈಗ ನೋಡಿರಿ ಈ ಸ್ಟ್ರಕ್ಚರ್ ಏನು ಡಿಫ್ರೆಂಟ್ ಆಯಿತು, ನೀವು ಇದು ಬೇರೆ ಬೇರೆ ಅನ್ನಂಗಿಲ್ಲ ರೀ. ಈಗ ಇದೆರಡು ಏನಿದೆ ಸೇಮ್ ಇವು, ಯಾಕಂದ್ರೆ ನೀವು ಜಸ್ಟ್ ಏನು ಮಾಡಿರಿ, ಇಲ್ಲೇ ಈ ಒಂದು ಬಾಂಡನ್ನು ಈ ಕಡೆ ಇಟ್ಟಿದ್ದೀರಿ, ಹೌದಾ? ಇಲ್ಲಿ ಏನದು ಸೆಕೆಂಡ್ ಕಾರ್ಬನ್ ಐಟಮ್ಗೆ ಇಲ್ಲಿ ಬಂದದ ಬಾಂಡು, ಈ ಸೆಕೆಂಡ್ ಕಾರ್ಬನ್ ಐಟಮ್ಗೆ ಇಲ್ಲಿ ಬಂದಿದೆ ಬಾಂಡು. ಓಕೆ, ಹಾಗಾದರೆ ಇದು 1ನೇ ಸ್ಟ್ರಕ್ಚರು, ಇದು 2ನೇ ಸ್ಟ್ರಕ್ಚರ್. ನೆಕ್ಸ್ಟು ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇದು ಒಂದು ಸ್ಟ್ರಕ್ಚರು. ನೆಕ್ಸ್ಟು ಇಲ್ಲೊಂದದ, ಇದನ್ನು ಈ ಥರ ಸ್ಟ್ರಕ್ಚರ್ ಮಾಡ್ತಾನೆ. ನೆಕ್ಸ್ಟು ಓಕೆ, ಇದನ್ನು ಇಲ್ಲಿ ಸ್ಟ್ರಕ್ಚರ್ ಕೊಡ್ಬೋದು, ಹೌದಾ? ಓಕೆ, ದೇರ್ ಆರ್ ಟೋಟಲ್ 5 isomers are present. Total 5 isomers are present for the compound which containing molecular formula C6H14. Therefore, correct answer is option D. Option D, 5 isomers. Okay, next very important questions on exercise 4, applied multiple choice questions, students. Identify the keto form of the following enol. Identify the keto form of the following enol. Yes, ಇಲ್ಲಿ ಒಂದು ಕಂಪೌಂಡ್ ಸ್ಟ್ರಕ್ಚರ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಇನಾಲ್ ಅದರಲ್ಲಿ. Keto form of the following enol is. First I write the enol to keto form of the given compound structure. I write the similar structure here. This one is OH and this one contain double bond and here single bond. Is it right? Yes. Here, yes, here 1 2 3 4 5. Is it right? Yes, here ketone form, this is alcoholic form, this is keto, and this one is enol form. Is it right? Yes. What is the name of this compound? Students, remember the name of the compound is, I write like this, E 3-pentene 2-ol. Means option B is the right answer. Remember students, if the two groups with higher priority are present on opposite sides of the double bond, then this is E isomer. If elements, E isomer from, means this E is taken from Germany, is opposite, means opposite inside, meaning ಏನದು E ಅಂದ್ರೆ opposite side. Students, if the two groups with higher priorities are on the same side on the double bond, then it is Z isomer. Z means together. Therefore, the correct answer for this question is option B. Next, question number 12, students. Ethoxyethane and methoxypropane are. Ethoxyethane and methoxypropane are. Okay, I think in the theory class I already discussed about this question. What is the correct answer for this question, students? Ethoxyethane. Ethoxyethane means the structure is C2, I write here C2H5O, C2H5, ethoxyethane. Next, another one, methoxy, CS3O, methoxypropane. Yes, I write CH2, CH2, CS3. Is it right? Methoxypropane. Yes, these are an example for metamers. Is it right? Yes, therefore the correct answer for this question is metamers. Students, next question number 23. The number of structural and configurational isomers of a bromo compound C5H9Br formed by the addition of HBr to 2-pentyne respectively are. Okay, observe question carefully. The number of structural and configurational isomers, ಏನಂತ structural ಎಷ್ಟದಾವು ಮತ್ತು configurational isomers of bromo compound when C5H9Br formed by the addition of HBr to 2-pentyne. HBr ಅನ್ನು 2-pentyne ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ ಅಥವಾ ರಿಯಾಕ್ಷನ್ಗೆ ಒಳಪಡಿಸಿದಾಗ C5H9Br ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಇರ್ತಕ್ಕಂಥ ಕಂಪೌಂಡ್ ಸಿಗ್ತದಂತ. ಆ ಕಂಪೌಂಡ್ದೊಳಗಿರ್ತಕ್ಕಂಥ ಸ್ಟ್ರಕ್ಚರಲ್ ಮತ್ತು ಕಾನ್ಫಿಗರೇಷನಲ್ ಐಸೋಮರ್ಸ್ ಎಷ್ಟು ಅಂತ ಕೇಳಿದ್ದಾರೆ. Yes, students, according to the given formula of the compound C5H9Br, when HBr undergoes addition to 2-pentyne, is it right? 2-pentyne, the isomers formed are, some isomer structures are right on the here. Yes, one is, it's like appear like this, Br double bond C H and here C. Is it right? Yes, it shows one structural isomer, structural isomer 1 and geometrical 2. Geometrical 2. What are those? Cis and transform. Is it right? Yes. Next, if you write the structure like this, here H, here double bond C, you only write single bond C. I write Br here and 1C here. And this structure here in this, the structural isomers are only one. Next, geometrical isomers also here. Geometrical isomers are 2. Therefore, total 4 geometrical isomers. Is it right? And 2 structural isomers. 2 structural isomers and 4 geometrical isomers. Where is the answer in the given options? 2 structural isomers and 4 geometrical isomers. Therefore, option B is the right answer. Option B is the right answer. Okay, students, next question number 27. How many stereoisomers of phenyl propylene oxide are there? How many stereoisomers of phenyl propylene oxides are there? Okay, students, phenyl for propylene oxide structures are given here. Okay, observe the given compound carefully. It contains stereoisomers like this. Here, yes, I write one H and one CS3 here, and here I write H only, and here C6H5. It's phenyl group. Next, another one structure. I write H here, and here CS3, and here C6H5, here H. Yes, students, each structure have 2 configurations. Therefore, 4 stereoisomers are formed. 4 stereoisomers. Therefore, correct answer for this question is option C. Each structure will have 2 configurations. ಪ್ರತಿಯೊಂದು ಸ್ಟ್ರಕ್ಚರ್ನ 2 ವಿಧದಲ್ಲಿ ಬರೀಬಹುದು. ಅಂದರೆ ಅಲ್ಲಿ ಅಟಮ್ ಡಿಫ್ರೆಂಟ್ ಮಾಡಿ ಬರೀಬಹುದು. ಹಾಗಾದರೆ ಟೋಟಲ್ 4 ಸ್ಟ್ರಕ್ಚರ್ ಸಿಗ್ತಾವೆ ಇಲ್ಲಿ. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನಂಬರ್ 29 ಸ್ಟೂಡೆಂಟ್ಸ್. The structure of allene is CH2 double bond C double bond CH2. Is it right? Yes. Options are given: staggered, option B planar, option C eclipse, option D none of these. Students, remember, I write the allene structure once again here. It is appeared like this: C double bond C double bond C. Here I write dash dash H and one H. Allene or allenes are the organic compounds in which one carbon atom has double bonds with each of its 2 adjacent carbon centers. Yes, left half of the allene is perpendicular to right half. Therefore, allene structure has staggered form. Remember, this one of the theoretical question. It has staggered formation. Means structure of allene is a staggered form. Next, question number 33 students. Which of the following optically active compounds racemizes in dilute KOH bar CS3OH, means methanol solution? Which of the following optically active compounds racemizes in dilute potassium hydroxide and methanol solution? Option A is given one structure, as well as in B, C and D with respect to structures. Students, when you come to the question, the compound containing carbonyl group, you know carbonyl group is, observe like this, carbonyl group. Is it right? Yes. The compounds containing carbonyl group which is adjacent to a symmetric carbon atom carrying a hydrogen easily racemize. You remember this point. Which type of compounds? The compounds containing carbonyl group and adjacent to the asymmetric carbon atom carrying hydrogen easily racemize. Therefore, option D is the right answer for this question. because it containing carbonyl group which contain or which is asymmetric carbon atom, which is adjacent to a symmetric carbon atom carrying a hydrogen easily racemize. The correct answer for this question is option D, because it contains carbonyl group which is adjacent to a symmetric carbon atom. Is it right? Yes. Next, last question, students. 37th one. The number of metamers given by the compound. Yes, the number of metamers given by the compound. Option A 3, option B 4, option C 5, option D 6. Okay, students, I write some metamer structures here. Okay, containing same molecular formula. Yes, CH2OCS3. It is one structure. And if you try this, you write another structure like this. This is OCS3 and this one is CS3. And okay, here this one is OCS3 and this one is CS3, and fourth one is here CS3 and here OCS3. Is it right? Okay, students, these are four structures which shows the metamers of the given compound. Therefore, the correct answer for this question is option B. It contains, means the given compound contains 4 metamers. Okay, students, in the next video we will see some more questions with explanation. Thank you.